Testing values. Number one, what is the maximum area in square feet of a rectangular enclosure that can be made with 60 feet of fencing? Let's just pick a value for the length and the width. So let's just say the length is 10. And now we can't pick whatever we want for the width because we have to make it work with 60 feet of fencing. So if it was a rectangle, that would be a width of 20 because 10 plus 10 plus 20 plus 20 equals 60. If we put that in our calculator, that is going to give us an area of 200. So that is a number to beat. So now let's play around with that. Now that doesn't mean that that is the maximum area. So that's why this is testing values, because we've got to try out a different value to see if we can beat 20. Well, let's say the width is length is 12. That would make our width 18, because 12 plus 12 plus 18 plus 18 will add up to 60. Now 12 times 18 in our calculator would get us 216. So that would beat our previous area. So it looks like we're moving in the right direction here. Let's try making that 14, and then this would be 16, because again, that adds up to 60. So if we did 14 times 16, that would put us at 224. And once again, we've beaten that. Let's try 15 and 15. Put that in our calculator. That'll get us 225. And then you'll see if we go the reverse here and do this one is 16 and this is 14, we start dropping again. So now we know that our maximum that we can get is a square, length of 15, width of 15, and that gets us an area of 225, which means the maximum area we got is 225. Number two, a triangle has base 4 inches long and height 6 inches. When the length and the width are each increased by x inches, the area of the triangle doubles. What is the value of x? So let's just, we'll start with 1/2 base times height, right? That is our area of a triangle. So if we plug in what we got there, we have 1/2 times 4 times 6. You want to put all that in your calculator. That's going to get you an area of 12. And so we're looking for something that is going to double that. So we're trying to get an area, goal area of 24. So let's just say x is equal to 1, right? So that would mean, and it's saying the length and the width are each increased by x inches. So that would mean that our new width, or rather base, is 5, b equals 5, and our new height equals, it was originally 6, so now it's 7. So if we plug that into 1/2 base times height, we would get 1/2 times 5 times 7. That's going to be, you want to put in your calculator, 35 times 1/2 is not 24. So let's then go with x equals 2. So that would mean that our new base equals 6 inches. Our new height equals 8 inches. 1/2 base times height is going to be 1/2 times 6 times 8, 48 divided by 2. That is going to give us a goal of 24. So that means that x is equal to 2. Number 3, which of the following is the set of all real numbers x that satisfy x minus 7 is greater than x minus 4? Let's just get rid of these for the moment. So let's kind of pick a number here. Let's say x is equal to 2. So if we plug that in right here, actually, I guess I can just do it like this. 2 minus 7, and actually, no, I'm going to 2 minus 7, 2 minus 4. That would get us negative 5 is greater than negative 2. That is not true. Let's try let's try 0. If we plugged in 0 for x, that would get us 0. That would get us negative 7 is greater than negative 4. That's also not true. Let's try a negative value, though. Let's try x is equal to negative 2. So if we plugged in negative 2 here, that would get us negative 9 is greater than or equal to negative 6, which, again, that is not true. Right? So none of the values we picked work, which means that it has to be the empty set. And the reason it's the empty set is that if you look at, this is saying that a number minus 7 is greater than a number minus 4, and that can't ever be true, because a number minus a big value is never going to be greater than a number minus a smaller value. But again, you don't have to understand that conceptually if you properly use the strategy of testing values. Number 4, as y increases without bound, the value of y over y minus 5 most closely approaches. So let's pick a value for y here, and let's just say y is equal to, and now it says as y increases without bound. So that means that y increases as high as you can go. So let's just try like y equals, let's go with whatever that number is. Billion, I think. I don't know. It doesn't matter. Let's plug it into our calculator. So that's going to be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, divided by, and now we've got to make sure you put in your calculator the parentheses around the denominator, because otherwise it gets screwed up in your calculator. So then it'll be y minus 5. So in this case, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, minus 5, end parentheses, equal sign. That's going to be 1 point, whole bunch of zeros, and then a 5. So it looks like, now you could, if you wanted to, plug in a different number, but it sure looks like we are most closely approaching 1, which is C. Number 5, cosine squared theta minus 3 plus sine squared theta equals question mark. So we got theta here, which we could pick a number for. So let's just say that theta is equal to 2. And now when we plug that into our calculator, you'll hit cosine. And now you're going to put it in your calculator a little different than it reads right here, because in your calculator, you can't actually put the squared right there. So you have to do it like this, cosine 2, and then put the squared right there. So it'll look like this when you plug it into your calculator. Sine 2. And then when we plug that in our calculator, let's go ahead and do that. So that is 2 raised to the second power minus 3. I got a syntax error, but that's because I'm being sloppy. If you go ahead and plug that all into your calculator very carefully, depending on your calculator, you might need to be careful with it and put it in something like this. But when you put that in your calculator, you should end up with -2. And now the reason for that is that cosine squared theta plus sine squared theta is always equal to 1. So if we kind of rewrite that, this right here is always, no matter what theta is, that is always equal to 1. So basically we have 1 minus 3. Number 6, if x doesn't equal 7, which of the following is equivalent to 3x minus 21? Well, this is an easy one. Let's just pick a value for x and plug that into our calculator. So let's just say x is equal to, 2. And if we plug that into our calculator, now be careful with the parentheses here, but if you plug that into your calculator, just like it's written right there, and then raise to the 0 power, you should get 1. And the reason for that is that anything to the 0 with power is equal to 1. And so no matter what you plug in here for x, that should get you 1. Number 7, I'm running out of time here. If angle W plus angle X equals 90, blah, blah, blah. So let's just pick values for W, X, Y, and Z that work with the parameters here. So if we have angle W, let's just say W is equal to 40. And that would mean that X would have to equal 50 degrees, right? Now, they're telling us we just picked the number that this was equal to 40. So that means that angle Y here would have to be 140, right? Oops, 140. And then if we know that, and then it says angle X plus angle Z has to equal 180. Well, we know from down there that angle X is equal to 50. 50 plus Z equals 180. That means that Z must equal 130. 130. And so then it's asking for Y plus Z. Well, Y plus Z, 140 plus 130 is equal to 270. And that will work for any values you pick. And then finally here we got the common difference in particular arithmetic sequence is 2/3. What is the difference between the mean and median of the first 5 terms? So they don't give us what any of the terms are. They only give us the common difference. So what we can do is just go, let's say the first value is 2/3, and then we go up by maybe, let's say 1/3 each time. And so 4/3 plus 5/3 plus 6/3 plus 7/3. How many? 1, 2, 3, 4, 5, 6. 5 terms. First 5 terms. So our median you will see is 4/3. And now if we plug all of these into our calculator and divide by 5, that will also be 4/3, which means that the answer is a 0 difference between mean and median.